Suppose the following experiment is performed. An object of mass 0.25 kilograms, M1, is slid on a frictionless surface into a dark room where it strikes an initially stationary object of mass 0.4 kilograms, M2. The 0.25 kg object emerges from the room at an angle of 45 degrees with its incoming direction. The speed of the 0.25 kg object is originally 2 meters per second and is 1.5 meters per second after the collision. Calculate the magnitude and direction of the velocity of the 0.4 kg object after the collision. This problem is based on the two-dimensional collision. Here what is happening? A mass of 0.25 kg slides in a dark room with a velocity of 2 meters per second. And it hits another mass of 0.4 kilograms. And after hitting that mass, it emerges with a velocity of 1.5 meters per second, making an angle 45 degrees with the initial direction. Our aim is to find out the velocity of the second object, that is, whose mass is 0.4 kilograms after the collision. Because initially the second object, that is 0.4 kilogram mass, is at rest. So let us enter the data. M1 is 0.25 kilograms, M2 is 0.4 kilograms. Initial velocity of the first object is 2 meters per second. Initial velocity of the second object is 0 because it is at rest or stationary. And then final velocity of the first object is 1.5 meters per second and is making an angle of 45 degrees with the initial direction. Now we have to find out the final velocity of the second object and its direction. So this is a collision. We don't know whether it is the elastic collision or inelastic collision, but whatever may be the collision, the momentum is conserved. Therefore, initial momentum is equal to final momentum, or sigma P is equal to 0. Okay. Now, PA is equal to PF means M1V1 plus M2V2 is equal to M1V1 dash plus M2V2 dash. Whereas M1 is the mass of the first object, V1 is the velocity of the first object, and then M2 is the velocity of mass of the second object, and V2 is the velocity of the second object. And V1 dash is the velocity of the second object, first object after the collision, whereas V2 dash is the velocity of the second object after the collision. Now, this is a two-dimensional collision, and initially for the first object and second object, both the objects, the x dimension momentum is there. Therefore, we will take the x component and first we will equate the x components, then we go for the y components. Now, what is the x component momentum of the first object? Mass into velocity. Okay, so 0.25 kilograms and 2 meters. And what is the momentum of the second object? 0, because the object is at rest, mass into velocity becomes 0. Now, what is the final momentum of the first object along the x direction? So 0.25 times 1.5, and then it is making an angle of 45 degrees. X dimension is cos component. Therefore, we have to take cos 45, adjacent side now. For this angle, this x dimension is adjacent side. So therefore, we have to take cos 45. And then next, the second object, we don't know. So therefore, we will take 0.4 into V2F cos theta 2. Okay. Now, on solving this one, we will get V2F cos theta 2 is equal to 0.5870. Next, we go for the y component momentum. So when we look at the y component momentum, initially, the first object is traveling only along the x direction and not in the y direction. Therefore, y component momentum is 0. And for second mass, it is obviously 0 because it is at rest. Therefore, initial momentum of the both the objects is 0. And then final momentum of the objects we have to write. So here, it is the first object is making an angle of 45 degrees with the original direction. So we are taking the y component, means it is the opposite side to the angle. Therefore, we have to take the sine component. So putting the sine, plugging in the values in the equation, M1V1 plus M2V2 is equal to M1V1 dash plus M2V2 dash for the y component momentum. We get these values. So on solving, we get V2F sine theta 2 is equal to minus 0.6629. Now we have to find out the tan theta. Okay, so tan theta is equal to pi by x. Therefore, minus 0.6629 divided by 0.5870 is equal to minus 1.129. Theta is equal to negative 48.47 degrees. So negative sign indicates that the second object is going below the horizontal. So this is the picture here. I have redrawn the picture. So this is the first object. It collides with the stationary object and then moves at an angle of 45 moves with a velocity of 0.5 meters per second, making an angle 45 degrees with the initial direction. And after the collision, the second object moves in a making an angle of 48.47 degrees below the horizontal. Now we have to find out the velocity of the second object. So for that, we will plug in the theta value. Here V2F cos theta 2 is equal to V2F cos theta 2 is equal to 0.5870, and we plug in the theta value as minus 48.47 degrees. We get V2F is equal to 0.8854 meters per second. So this is the value. We get the velocity of the second object as 0.8854 meters per second, making an angle of 48.47 degrees below the horizontal. So this is the answer for this question. Okay, hope this helps. Thank you. Bye-bye.